using substitution. So this is another technique. The last one that you did was solving by graphing, where you found the intersection of the lines, and that was the solution for both of the equations. It could be more than two equations as well. But this time, we're going to be using solving by substitution. So we're going to be taking one equation and actually moving it inside of the other equation. So first of all, here's my system. Y equals 4x and 3x plus y equals negative 21. We're going to solve one equation for either x or y. And nicely enough, this one is already solved for y. Y is by itself. So it's done for us. Y equals 4x. Then what we're going to be doing is we're substituting that into the other equation where y was, because what is y equal to? It's equal to 4x. So instead of this y, I'm going to write 4x. So that's what's done here. See, it was 3x plus y, now it's 3x plus 4x, because 4x is the same as y. And then you will solve the new equation. So what is 3x plus 4x? It is 7x. Still equals negative 21. Divide both sides by 7. X is negative 3. So now you know the x coordinate of that intersection point. How would you find the y coordinate? You would then take that x coordinate and plug it back into one of the two original equations. Well, which one would be easier? The first one, right? Because then you only have to multiply it by 4. So if you multiply by 4, 4 times negative 3 is negative 12. So the solution to this system is negative 3, comma, negative 12. If you graph them out, they will intersect at negative 3, negative 12. So this is actually a little shorter probably than graphing, unless you had your graph paper ready to go. You also don't have to solve both for y. When we graphed before, we had to solve for y. That's a step we don't need to do. We will need to solve at least one for y if they don't give us one. You could also solve for x, actually. So let's look at some of the practice problems. So right here, we have a system, x plus y equals 10, and 5x minus y equals 2. So we need to get one variable, like it said in step 1, one variable by itself. I'm going to get x by itself just because I want to show you that you can do it either way. In doing so, I would subtract y to both sides. So my new equation is x equals negative y plus 10. I subtracted that y to both sides. So now, instead of x in the second equation, once I have this, I plug it into the second equation for x. So it's 5 times x. But what is x equal to? Negative y, and I'll make it negative 1, y plus 10. That goes in parentheses because the whole thing gets multiplied by 5. And then you rewrite the rest of the problem. So minus y, or plus negative 1y, equals 2. So I solved the first one for x. It gets plugged into the second one for that x. So we have to distribute. And we get negative 5y plus 50 plus negative 1y equals 2. Combine like terms, they're on the same side, so they make negative 6y plus 50 equals 2. Subtract 50 to both sides, gets me negative 6y equals negative 48. Divide by negative 6, y is 8. Now that's just half the problem, right? I found y is 8. So over here, I'm going to then take this y is 8 and I can plug it into either equation. Which one would be easier? The first one, right? X plus y is 8 equals 10. So what does x have to be? X has to be 2. So my solution is 2, 8. And if I take 2, 8, and I plug it into both of the equations, it's going to work. So I'm going to do a check on a separate piece of paper since I ran out of room there. Here's my check. So 2, 8 is my solution, I believe. So 2 plus 8 equals question 10. Well, of course it does. 10 equals 10, so that was the first equation. And then I'm going to check the second equation. The second equation was 5x minus y equals 2, and I'm plugging 2 in for x and 8 in for y. So it becomes 5 times 2 minus 8 equals question 2. 5 times 2 is 10. What is 10 minus 8? It's 2. So it works. Okay. You could also graph both of them out and see that intersection point at 2, 8. Okay, so let's do another one. I'm just going to get another, I'm going to work on another piece of paper here. You may want to do that as well if you can't get them to all fit. So number 2, it already has the very first equation, solve for y. So that is a bonus when that happens. So we're going to take it and we're going to plug that into the second equation. So instead of y, I'm going to have parentheses. I'm going to say what y equals, which is 2x minus 2, and then finish the equation off. It was equals 10 there. So we do this distributive property. We have 2x plus 3x times 2x is 6x, plus 3 times negative 2 is negative 6. Combine like terms, 8x plus negative 6 equals 10. 8x equals, add 6 to both sides, 16. Divide by 8, x is 2. Now you need to take that and plug it into whichever equation you want that looks easier. I would say the first one looks easier to plug 2 in. So it's y minus 2. See, there was my original first equation again. And I plugged 2 in for x. So y equals 2 times 2, which is 4. Y is also 2. So my solution, I write it as an ordered pair with parentheses, is 2, 2. And you would plug it back in to check to make sure it worked. Okay, we're going to do one more together. And then I'm going to set you loose on 4, 5, and 6. So here are my 2 equations. Neither one has a variable by itself. That's a bummer. So any of them you're able to solve to get by itself. But one is definitely easier than the rest. Can you tell which one would be easiest to get by itself? It's that y right there, because there's nothing in front of it besides the negative 1, which is easy to take care of. So I'm going to rewrite that equation. This is why we did that solving for y practice in the last problem. So you subtract 2x, you get negative y, or negative 1y, equals negative 2x plus 5. How do you get rid of a negative when it's multiplied? You divide everything by negative. So y actually equals 2x minus 5, or plus negative 5. So that was the second equation I solved. So then I plug it back into the first equation. I'll rewrite the first equation. It was 2x minus 3y equals 7. So I'm going to take that y that I found and I'm going to plug it in here. I don't want to mess up, so I'm going to make sure I make this plus a negative 3 there, so that that negative 3 gets multiplied by everything on the inside. So I have 2x plus negative 3 times y. Y is 2x plus negative 5 equals 7. You're going to distribute. So 2x plus negative 6x plus 15 equals 7. So negative 4x plus 15 equals 7. Subtract 15. Negative 4x equals negative 8. Divide by negative 4. X is 2 again. All right. Now you're going to take that and you're going to plug it into one of the 2 original equations. Don't necessarily plug it in this one, because if you messed it up, then you'll never find out. So we're going to plug it in one of the 2 original equations. So I'm just going to pick the first one. Why not? So it's 2x minus 3y equals 7. It wasn't obvious that one was easier than the other, so I just went with the first one. So now it's 2 times 2, because x was 2, plus a negative 3y equals 7, which is 4. Subtract 4, negative 3y equals 3. Divide by negative 3, y is negative 1. So we have 2, negative 1 as our solution. Okay, zoom out a little more, see if I can get that all on one overhead. There you go. Okay, so number 4, you're going to do on your own here, and then you're going to come back and check and see if you got it correct. Number 4 is a nice one, isn't it? Because they already have a variable by itself, so go with it. All right, go ahead, pause the video and see how you do. All right, your solution should have been 3, 9. I've used this x, I plugged it in there, the y minus 6, distribute, combine like terms, solve for y, it's 9. Take that, plug it back in the original top equation because it's easier. 9 minus 6 is 3. And then it's 3 comma 9 because it's x comma y. Okay, see, Mrs. Wyman, if you have a question about that one. Otherwise, proceed to number 5. Okay, so the next one is 5, 4. You plugged in x equals for this x. There was no distributing, so you just combine like terms, solve for y. It was 4. Take that, plug it back in the top equation, and solve and get x is 5. So those two were pretty easy because one variable was already alone. If you look at number 6, no variable is alone. So what you need to do is you need to decide. And honestly, I would either solve for this y or this x. They're both alone. They're both pretty easy as far as you just have to get rid of the other item there. So it doesn't matter. So when I do this problem, you're going to pause it, you're going to do it, and when we come back, you may have solved for a different variable than me, but we'll still get the same solution if we both did it right. So go ahead and pause. Don't just watch my answer and copy it down. You need to work it out yourself. Go ahead and pause and try it out, and then come back and watch. All right, so last problem, the answer is 4, 2. Now, we may have done the same thing, we may have not. I solved the second equation for x, so I ended up with 3y minus 2 over there by itself. And then I plugged it in for x into the original, the top equation, distribute, combine like terms, solve for y. Then I took that y, I can plug it into either original. I plugged it into the top, solve for x, x was 4. All right, so hopefully you're good on that. If you're not good on that stuff, just see Mrs. Wyman. She'll help you through it. And if you are good, you're continuing to the next page. You're solving these by substitution and following the directions to get the answer to the question up at the top. Your work is going to go on this blank piece of paper that's right next to it. Great job.